Start with the first presentation. Marcel, please reach me on the stage. I give you the floor to introduce to all the audience the high-speed ISOBUS.
Okay, thank you to attend this presentation about the HSI. At first, who I am, my name is Marcel Urban. I work since January 2023 for the AEF. And in the AEF, I'm responsible for the AEF database, for the AEF SharePoint, and I'm also a member of the Service and Diagnostic group in the AEF. So, today we talk a little bit of the high-speed ISOBUS, but first we go a little bit back in 2001. The normal ISOBUS is presented on the Agritechnica in Hanover. In 2005, the first machines are in the market in Europe. In 2008, we founded the AEF with our core members because we have problems in the field with these interoperability. The manufacturers interpret the ISO standard in different ways. So all members came together and set up the AEF and works on the ISO standard and how to interpret the ISO standard and set up guidelines. Then in 2014, the HSI ISOBUS team is founded in the AEF, and in 2022 the Joint Working Group 16 is founded. The Joint Working Group 16 is a combination from AEF members, from the earth-moving machineries, from the forestry machineries, and so on. But later we have also a slide of this. So at first I introduced the HSI team. The HSI is led by David Smart. He's a retired John Deere guy and is the team lead of the HSI group. Then we have Volker Brüll from class. He's deputy of the teams, and also in the HSI group we have some sub-teams, like for the physical layer, for the architecture, for the protocol, and for the diagnostics. And you can see each team is led by individual members of our companies. So we have John Deere for the physical layer, we have CNH, CCI, it's a competence center ISOBUS, and we have also CNH guy for the diagnostic group. The wireless group is moved out of the HSI team, so we founded also a team which is proposed all these wireless in-field communication stuff. So we have 25 active participants, but we have 110 registered people in the HSI group in the AEF. Okay, then some about the requirements and the use case. For the normal ISOBUS, we have sometimes when you have big machineries like big planters, big sprayers, have problems that the bandwidth in the ISOBUS is fully loaded. So the normal CAN bus is about 100 megabits, and the high-speed ISOBUS is a two-layer Ethernet communication, is around 1 gigabit per second. So we have real higher performance, and to also that we can use new needs in the ISOBUS. So today all these camera applications are proprietary by these manufacturers, and with this high-speed ISOBUS we can implement direct, or we can connect direct cameras to the high-speed ISOBUS system. Okay, high-level objectives from the HSI is high performance, much faster than the normal ISOBUS, and data logging of numerous signals. Then it's only overview slide. We have here the long lifespan of the HSI. So it takes more than 10 years to improve this HSI to the market. The same, the ISOBUS to the market. The same is for the HSI. We are today at the 10th anniversary of this HSI's development in the AEF, but we are not done with the development. It's so huge. Okay, so only a picture. So I will skip this part. So then we come to the physical layer of the HSI. We are already done with the ISO team and the AEF team to set up a physical layer and an HSI connector. So we have a 4-pin connector, 2 pins for power and 2 pins for the Ethernet connection. And we decided in the AEF to use this 1000 base T1 type B connection because we have large machines, we have big machines, and we have the maximum of 40 meters network range with these cables and around 4 or 5 connections in one system. So here's something about the HSI architecture. So we can see also in the future the ISOBUS is not gone. We leave the ISOBUS. We have here the normal ISOBUS connection, and in blue we have the HSI connection. We have here our camera systems. We have a second implement also with camera system and some subsystems. And also in the future we have this wireless infield communication, but which we can connect other implements and other tractors to the whole system. So then we have the functionality reuse. So today when we talk about ISOBUS, we talk about functionalities like task controller, like universal terminal, file server, aux functionalities, but all these functionalities I will reuse with these HSI system. So industry collaboration. So we decided to take the 1000 base T1. It's the same standard like in the automotive Ethernet, and collaborating with similar needs industry groups like what I say is the mining, the forestry, and the what I missed is the truck and trailer group. It's also part of the joint working group. Yes, the joint working group was founded in 2022, and we will see we have the construction, the ag industry, and truck and trailer group, and some other ISO groups here with the TC 127, TC 23, the VDA group, TC 82, and so on. So you can see onward equipment, mining equipment, machinery, forestry, and all these groups works together in one group close together with the AEF. So that's the part of an ISO standard. It's only a slide to present you. Please make a picture. I cannot say a lot of these things, but later please come to me. I can show you something about that. Then we have an AEF Plugfest. An AEF Plugfest for ISOBUS is like a little bit of speed dating. So there comes implements and tractors at one place, and repeat it. And yeah, make off and connect together and can test the ISOBUS. The same we have since the sixth time the HSI, or we call it HSI Discovery Stations. So we have there around 12 participants. With participants we mean 12 manufacturers were there with different equipment to test their high-speed ISOBUS at the event. And the main outcomes was like test the ISOBUS commands, test the integration of digital cameras, and test the initial of HSI layers. So we really test, we have 40 meters of cable, we have different connections, and then we will test if the high-speed ISOBUS will stable. So same is, I have here some more bullet points for this command and control. Focus on universal terminal and task controller at the Plugfest. Then enhanced performance and visualization for the digital camera. Test with cameras and the monitors. Focus on the ISO norm. And the goal is plug and play functionality, reducing proprietary requirements for compatibilities and physical layers, what I say, inside big length of cables, will be data transmission and testing with HSI connectors, cables, and Ethernet chips for multiple suppliers. So at the Plugfest we have the manufacturers for digital cameras, we have the competence center ISOBUS, we have Anido, RT Systemtechnik for CAN tunneling testing, we're also competence center ISOBUS, Krone, John Deere, Topcon for physical layer testing was the suppliers, Rosenberger with the connectors, Etenovia with Ethernet chips, and Powell with network chips. And for protocol concept we have a CNH, OSB, and another time the CNH. Here are some pictures of the Discovery Station. So we can see there's a lot of cables, a lot of computers, a lot of implements. At the first day when they build up the equipment, nothing works, but at the second day, you can see not in the picture, but I will be there, and you can see that the camera streaming will work, that the functionality use will work, and also the old ISOBUS functionality will work on the HSI. Okay, thank you. And then I will hand over to Slavi with the AgIN presentation.
Thank you, Marcel. Just a few words, a short comment about this unprecedented industry connection, let's say, to speed up activities, because it's, I believe, the first time that happened for that 5 industries joined together to develop such a kind of physical layer and technology, and that really speeded up the development. More speed, more functionalities on the machine, more data to go on the cloud, and maybe that can be exchanged by different clouds from manufacturers. Slavi, join me on the stage. I give you the floor to present the Agricultural Interoperability Network Initiative.
Thank you, Alessio. This is mine. Okay. What a great place to meet. So what you have not mentioned, that the Plug Fest this year was also in Bologna. And yeah, so we have seen a great collaboration among all the OEMs that we have, and all the projects took that chance and meet up and talked about all the projects and content that we have in mind. So here you see a glimpse of the project and teams we have in AEF. Mainly focusing on the machine to machine and machine to implement interfaces, but we see that everyone, or almost everyone today, has an own cloud. Yeah? So he's sending the data up there, and that was not yet in scope of AEF. And that's what we changed now with introducing AgIN. What kind of situation are we facing when AEF is not resolving it, or when we do not have a joint common approach to make this data exchange happen in the cloud? That's what we see today. Yeah, so we have OEMs, we have implement manufacturers, we have software providers, and we have data hubs, we have routers, and then you want to stream the data through this environment, through this X sector environment with software, hardware, but you need really to study to understand how you want to do it today. Yeah, and that's what we want to address with AgIN. We want to simplify it. We want to introduce standardized interfaces and even standardize the environment for interfaces to add new interfaces and software and use cases easily to that environment. So we are filling here the gap, what you have seen before. Without this cloud-to-cloud connectivity, we are introducing this with AgIN. We are bringing the new standard through AEF, how those platforms, online platforms and cloud solutions can be interconnected. And FMIS has become also now part of it. Yeah? So they've been not yet too much in scope, but with this approach, with this initiative, they are highly invited to contribute to the solution area. So let me give you an overview what AgIN will address. Yeah? So here you see on the left-hand side, but the side doesn't matter, it is just easier to show it. On the left-hand side, we have all the OEMs connecting their equipment, their assets, how we say, to clouds. And then we have this environment of AgIN, where we have the cloud systems interconnected among each other. And we have also data hubs being part of this whole solution. While all the solutions that we see today are in a central way, where you connect your data to one cloud system, AgIN is more a network. That's why it's called Agricultural Interoperability Network. Yeah? So there we describe how cloud systems can be interconnected, but the connection itself needs to be established peer-to-peer from every participant in the network. So every party that has onboarded to AgIN and made the specification, signed the contracts, becomes a participant in the network. That's how we call them. AEF will have some central services. You might say it's like a phone book. Yeah? You will find there every participant in the network with the services provided by the participant, and also with a test and sample data that can be used to implement new use cases. Use cases are for us something that you need to understand on a business level. Yeah, so we stick away on within use cases from technical description, but are saying, okay, we want to do harvesting, we want to do machine tracking, we want to do what I have here, work orders, work records, so things that you are used to in your business. You want to do an operation, you want to make systems interoperable, but you need to understand, okay, not which data will be exchanged, but which use case can I resolve with this connection, with this support by participants in the network and cloud systems connected. Technically, below these use cases, we have the services. But that's more for all that are involved in the teams and are working really technically on the solution. And these services are here to visualize that this whole thing will be built with components, and components can be reused. So when we start to introduce these components in a productive environment, then we can easily add new use cases reusing existing components and services in the system. The farmer is the user, is the controller. So when we interconnect clouds, it's not like that all the data from one cloud will be copied to the other cloud. It will be always the user who decides which connection will be established. A user is expected to have in every cloud one account, and he will connect his one account to another account in a different cloud system. And then he decides which data he wants to push from one environment to the other environment. So it wouldn't be any of the OEMs or software providers who would decide which data will be moved, but which data can be moved. Yeah? So that's what we are building, a can environment. You can later move data from one environment to the other. But the user, the farmer, the operator, whoever uses this environment is the one who controls the data flow. I also have a detailed slide, but it's not like to digging into it. When we talk about a service, then we have many different areas we need to touch and address. We have partners like a gateway, we work together with other teams, we have aspects like API, we have services, we have descriptions, we have legal topics, we have a database and registry, we have test simulators and a data model. It's not like that when you hear one of these words that people are mixing it up. It's complex, and sometimes we are talking about specific aspects of a use case, of a service, of a data model. And with all these items, you see how many things needs to be addressed to resolve it. Yeah? And so we are working on all these topics, mainly today, for example, also with Egg Gateway, they are working on a proper data model with ADAPT, and the ADAPT standardization will be a good foundation for us to not only build data models for the ag sector, but even beyond for chemical industry, food chain industry, for retail and others. Yeah? So where we will start to cross the sector from ag to other sectors where data will be also used and is required. Here you see how an onboarding process of a participant can be expected in AgIN. So we start with signing into the legal framework, so one contract for everyone. So if you want to participate in the network, you are signing a contract with AEF today, and then you become part of this environment. So you do not need to sign any more peer-to-peer data exchange contracts. Looking into our world today, if you have 20 parties out there and you want to get every party signed a contract, then you end up with hundreds of contracts and they differ. And this difference is keeping some of our legal folks really busy. And we want to simplify that point with a legal framework. So first, signing legal framework, you're done with it. One-time effort. Then you receive the interface specification, how to implement it. You implement it, make a conformance test, and you will be listed in the database of AEF. So in the phone book, so other platforms can call now your services. And to accelerate this even, we have introduced a connector so that not every party, not every network participant has to implement these initial services by himself, but that we make this development effort on our side, and parties who want to participate in the network just need to integrate this connector instead of developing it, and that will help us as well to accelerate this whole initiative by skipping a little bit this detailed specification effort and dealing with the different variants of implementation of connections to the network. How would it look like from a platform perspective? So if we have a platform, the platform will receive from the phone book all the participants, all the services which are available, and each platform would visualize the services available and the participants. A user would log in into the platform of choice, would select the platform he wants to connect to, and would type the credential from the other account to get the connection established. You might know it from Amazon and PayPal. If you used it once, it's pretty much the same. It's OAuth 2. You need to have two accounts that allow each other to exchange data. Our team has above 100 participants today. We have 4, meanwhile even 5 subgroups working on different topics. As stated, we have the legal topic, product, where we design and craft use cases, solution environment, where we craft this concept and architectural approaches, like also OAuth, authorization, authentication, security topics, how we are building data models, how we are validating all the stuff. And the Common Connector is also recently a new started working group within our team. So the development of the Common Connector is now, has started 1 month ago. So we are really coding now. It's not in paperwork anymore. That's an outlook. So what is our intention? What do we want to achieve in the next years? So 2024, that's where we are in. So the use cases are defined. The configuration services are in development. The Common Connector development has also started. And we expect next year to start with onboarding of the first participants to the network, to get a demonstrator on the Agritechnica, and the year after to roll this product out. So to have a pilot, having the first use cases implemented there, and also to start to work on the CEDS use cases. So this is a Common European Agriculture Data Space Initiative from the EU, where we are also part of that project and will bring additional use cases on the European level to cross the ag sector towards other environments like, as stated, retail, but also national and local authorities are parts of this game, where again the user, the farmer, will be the one having the account, but that shall simplify the data exchange between the system at the end, so that you can easily expect it's working, yeah, and do not need first to read the instruction. Yeah, what my experience is today, when I get a product and I have to read the instruction, the specification, before I can use it, it feels a little bit broken. Yeah, it needs to be intuitive, and so that's where we want to go. Thank you.
Thank you, Slavi. And thanks to this delightful sound of the escalator, which is making us so happy during this day. We talked about high-speed interface and high-speed ISOBUS, agriculture interoperability in the network, everything about interoperability and interconnections of machineries and data. And now we continue on that trend, talking about how interoperability comes into play when we talk about autonomous operation and autonomous machines. So, Michele Mantovani, Mattia D'Ambrosio from Autonomy Group of the AEF. Thank you for being here. I give you the floor for presenting the Autonomy Group.
Thank you very much, Alessio. I'm Michele Mantovani, working for CNH and ISOBUS enthusiast, let's say. All right, I'm here to introduce you to the AEF autonomy in AgIN project, right? So we started with guiding questions. So why was the autonomy in agriculture project founded? What is the mission and the purpose? What is our working methodology? What happened so far and what's next? So, autonomy agriculture, why was it founded? So, overall goal of autonomy, providing labor-saving, more efficient and sustainable work processes through machinery automation in the agriculture application domain. Here you see a change. It's a journey at the end from automation to autonomy. I like this word that I think that we define it into the AEF autonomy group. Automation. So it's a journey from, you can see here, the difference between the assisted operation is that the operator is sitting in the cab. So there is a human brain and digital brain. Into the roadmap, we are going to go into an unmanned operation where we're going to have just digital brain, digital eyes, and the operator will not be in the cab anymore. So probably we're not going to have a cab too. And the digital brain to do what? So mainly generic tasks, and those are just examples, right? So generic task navigation, path planning, localization and mapping, lateral and longitudinal control, collision avoidance, bystander detection, I would like to add too. Route planning, monitor machine function and make adjustment of, in particular, malfunction of the machine. Monitoring of and control of work quality, because in the previous presentation we heard about stressing operation. So even an experienced farmer, while seeding, is stressed. So I talked yesterday with a customer and he told me, when I finish seeding, I'm completely done. So I'm too stressed, it's very difficult. Let's imagine that we are going to be capable to make this through automation or either autonomy. And okay, so you can see the roadmap in less than 100 years from this to that. So those are just examples, right? But which are the common answered question that we had during the AEF Autonomy Day workshop? So in 2023, we met in Bologna here as AEF to all together, all OEM, and say, okay, I think we got a problem now. So we would like to go in autonomy. We would like to deliver autonomous solution into the market, but we're not ready. And all of this application there are troubles with normative interoperability. So we need to sit down together and find a solution. And the main question were, how I can create a cross-vendor automation ecosystem for agricultural technology. So cross-vendor, so not one-to-one, so one to multiple, all right? Which standards are necessary for achieving this and which existing one needs to be adapted? So functional safety, for example, so homologation, so there are troubles here. So every country has got its own normative. It's a mess. The mission, every activity that you start with a scope and a mission. So our mission is to enable the agricultural industry to answer challenges of autonomous machine with standards and technologies and technology for interoperability. And of course, ease of use, as said by Slavi. You see here, we don't talk anymore about tractor, we talk about traction unit. So the tractor can be a tractor, but it cannot be a tractor. It can also be a tractor without a cab, so a traction unit. We're talking about implement. We are talking about vendor of services, FMIS, path planner tools that can be running on the cloud. Because you need you don't have the operator in the cab. You need someone that creates the mission. Maybe the farmer is no more the operator. The farmer is the one creating the mission from his house. And all those parts are part of the autonomous system. Yeah? And we said interoperability. What interoperability really means? The interoperability describes the ability of systems, different systems, so implement, traction unit, cloud, to work together and application to communicate each other and work seamlessly together. The key component for interoperability is open standard. Anyway, this is a definition of Fraunhofer, but I think that is perfect. And you see there a schematic, so that we are gonna go in that direction. So we want the open standard. So today in the market, there are machines that are working in autonomy. Those are single machine, or there are machines with interoperability with proprietary partnership. So even the one that has got proprietary partnership, I'll say, okay, but we would like to sell our boat, our traction unit with others. We would like to use different implements, and that's why we are here. The purpose, the goal of the new autonomy in agriculture, the project, is to find a holistic approach to autonomous agriculture, prioritizing operator ease of use through alignment within the AEF and modification of the existing standard. This is what we said. It's a difference between a technical perspective and a social perspective. At the end, with the 5C schema in the middle, we would like to put together all these parts. So it's important. Connection, communication, configuration, computation, and coordination, all together, putting together all these pieces of the puzzle, we're going to be capable to complete our story. And again, the scope. We would define a scope for starting, otherwise it would be a nightmare. So we made some assumptions. Some of these assumptions are only consider autonomous in field work, not on-road autonomy. One autonomous traction unit implement combination working in one field. So with this, we are gonna say that platooning will be out of scope for the meantime. Okay, we're gonna start that way. We're gonna eat the elephant in pieces, and we're gonna start like this. Consideration of how we can make an autonomous operation easier. So as Lavi said, we don't want to read the operational manual, or we don't want to read a data sheet 100 pages long. We want to click and go. It ought to be easy. Multiple autonomous machine combination executing the same type of work in one field. So this one, yeah, it means that we can use a traction unit with multiple implements, so it can be front mounted, rear mounted, or also mounted on the roof. But we don't see now the platooning use cases where multiple traction unit will go in the same field. Multiple autonomous machine combination executing different consecutive type of work in one field. Yes, but independently. Collaboration between a manned and manned machine, of course, yes. We cannot stop it. And open standard for off-board planning and monitoring tools. So we need to define, probably will be a guideline like we did in the past for other systems like TIM, but we have to define a guideline that probably in the future will become an ISO, because we want everybody on the same page, sitting on the same table and looking at the same requirements. And with this, I'm gonna leave the floor to Mattia.
Hi, I'm Mattia D'Ambrosio. I'm working as a system engineer for in CNH, and I'm part of autonomous AEF team. And my focus is on explaining to you the user the problem that we have to face when we want to develop such a technology as autonomous systems. One is for sure the user experience. We want that the user can just manage the usage of the autonomous machine in a very easy way. And to do this, he needs to interface with what right now is the different control of the implement that today are managed by the UT, so the virtual terminal and the OP that are present at the virtual terminal. And we think that in the future, the operator needs to have the possibility to have remote desktop in which he can manage and he can control the work of his system. And to do this, we need to define an interface of the task controller, for example, as a solution, to control the function in an easier way. And also we need to have a simplification of the autonomous and non-autonomous interaction in order to find a really user-friendly interaction between the user and the machine. Then we have one of the big problem of this technology, that is the safety. We want to be sure that the use of this kind of technology is safety for all the people that can be present in the field. And to do this, probably we have some power unit or tractor unit that have implemented on board a perception system, but this is not sufficient when we have implement very big as a large square barrel, for example. In this case, we need also to have some kind of perception that is present on board in on the baler. And to do this, a possible solution is create a distributed perception systems that can allow to also the implement to detect unexpected obstacle and inform the power unit to stop the vehicle or to do some other function. For example, some deceleration, controlled deceleration. Then we have a focus on team and on the possibility that team implement already now are the possibilities that are present for the usage of team today. We want that the team implements can be used also in autonomous system, with autonomous system. And to do this, we need to define which is the role of team in the autonomous architecture, and probably we need to update team specification in order to use team functionality with autonomous solution. To work on this system, a system like autonomous, we defined a working methodology that have as a first step the definition of the user role and the user scenario in order to understand which is the function that we want on this kind of technology. Then the second step is derive these functionalities and its software components, and try to define each system component with a description, a behavior, and specify which is the input that he needs and the output that he can provide to the entire system. And this is for create a common understanding of the autonomy in the agriculture world. Then we have a step 3 in which we try to define an architecture connecting all of these different modules, for example, the remote supervisor or the system container module. And obviously, this is a procedure that it can be, it will be iterative. And then, as fourth step, we have a focus of the interface between the different modules, and we define which are the safety, the security, and the functional requirement for this interface. And also we have to understand which is the AEF team that are affected by this architecture, and try to draft a guideline of this interface with the sticks in the AEF teams. Then also we have to understand which will be the public interface and which are the company-specific interface between the different modules. And we are a team of 62 team members, and we want to have a documentation that is more transparent, and we choose to have a documentation for do this that is on Polarior, on Jira, for every IF member company, to so every company can review our works. And then we choose to organize our work with 3 different modalities. One is a weekly sub-team working, in which we are more focused on some aspect, for example, perception or functional safety. Then every 2 weeks we have a general presentation, a general meeting in which there is a presentation of the different sub-teams. And then every 3-4 months we have a face-to-face workshop of 2 or 4 days, in which we work together to try to define as much as possible all the previous steps that you see. And this is a timeline of our team. We have in April of 24 the approbation of IF steering committee and the presentation of the teams with a kickoff meeting. Then in July we have the first face-to-face workshop in Kaiserslautern, in which we defined the use case and we defined the needed functionalities that we want on our autonomous system. Then in the second face-to-face in September, we go deep in the specification of the components. And then in the end of November, we start to work with functional safety and security expert team in order to start a development in which both of the 2 important parts of security and safety are present. And then we want to define completely the components for the end of November. In December, we have a face-to-face in Nostenbrook, in which we want to define a functional architecture. And in February, we have the review of this work, and we want to finalize the use case. Instead, in the June of 2025, we hopefully have a final architecture that can be validated by a backtracking of the use case. And we have we will have also summit with the IF teams and our company to submit our architecture. And then we will pass to the definition of public company proprietary interface, and perform analysis of this interface and try to adapt the standard for with the existing teams in the AEF. Thank you for your attention.
Thank you very much to Mattia and Michele as well. I'd like to invite on the stage all the speakers. We have more than 10 minutes left, so if there is some question for the audience, I give you the microphone. Okay, we already have one.
Hi, thank you for your presentations. I have questions regarding the physical connections, so the connector part, right, of the standards that are built and that you are building, whether it's high performance or for autonomy. To what extent do you think that there will be a standard for all parts, or is there a limit to standardization?
Okay, so just we have to split it a little bit in between the different topics. The first one I would split. The first one is high-speed ISOBUS. We talked about that before. Now it is in discussion in the ISO, so the International Standardization Organization, and they when Marcel showed a very colorful picture. That picture was explaining all the parts of the standard which are developed already, which are underdeveloped, and which are being thought, let's say, for the future development. They cover different layers of the ISO-OSI model. Then the connector is actually almost done for the high-speed ISOBUS. And that means that we're going to have a standardized connector for the 1 gigabit data transfer between machineries. Then when we go to autonomy, is that gigabit enough for all the use cases? Who knows?
At the end, yes. So first point, the connector is standardized. The physical layer is standardized, it is defined. So there are players that are out in the market that are using and mounting this connector and using this technology in the field today for planter and large tractor. The point is, where do we need this bandwidth? So basically we need this bandwidth for digital camera. So Mattia made the example of distributed perception, right? So let's imagine that the camera is mounted on a tillage that is 10 meters long. You need to take this input from the tillage and carry this input into the tractor, because maybe the tractor has got the perception unit there, and for this reason, basically we need the high-speed ISOBUS. But high-speed ISOBUS is a good enabler not only for the autonomy. I said automation because if we need this tomorrow, and we want the operator sitting in the cab, but we want just to develop another system. So with the operator supervising the machine sitting in the cab, yeah, we can use it. So it's out in the market today without automation, at least for one application that I know, that I cannot tell. Thank you for the question.
Thanks.
Has your question been answered enough?
Yes.
Okay, there's another question down there. Thank you.
Thank you. First question, besides the sensor for automation outside the vehicle, like a radar or camera, inside the vehicle itself, are you exploring particular sensors such as steering control? And that was my first question. The second one, what type of level of safety do you need? I mean, is it PLD? Canopy safety, how are you exploring the certification level of the function, let's say steering or another one? Thank you.
Thank you for the question. So the first question, within AEF perimeter, we are not looking now at sensor mounted in the cab. We are looking at sensor perception mounted out of the cab. As I said before, we don't know if there is a cab. And but of course, as OEM, we are looking at a sensor like this to see operator awareness, for example, right? But those are not linked to automation. So those are not linked to autonomous. They can also be used for automation or normal usage in the field or in the road, okay? The question related to functional safety, the answer is it depends. So there is no a performance level which is defined, so it's PLD for everything. So the performance level is defined function by function, right? So you make the error for every function, you make the technical safety concept, and once you make the error of the steering under automation or under autonomous, you're gonna see which is the performance level that you reach. Same for speed, same for valves, same for rear reach. So it's a split of things. We're not gonna have, I think, performance level for the autonomous itself, but for some specific scenarios like bystander detection, yes. So probably my idea is to go through AEF paths. So as autonomy team, to move this discussion into the AEF functional safety team, which we started 2 weeks ago. I did it. And my expectation is that everybody into the world is looking for a number for those specific use cases. So, and the same for the distributed perception. So it's a matter of liability. How can I trust you? You're mounting the camera on your tillage, but your tillage doesn't belong to my tractor. So how can I trust you? And those discussions ought to be made as a within the AEF umbrella, because it's a matter of liability and we have to trust each other. So this is more or less.
Thank you.
Yeah, good for the question.
Thank you, Michele. Any additional question from the audience? About autonomy? Of course. Thank you.
Hi, my question is very simple. Do you see a relationship between AgIN and autonomy?
Okay, so I start. Yes, it's pretty easy because autonomy for us appears like a very attractive use case which will highly benefit from interoperability. And the connection, what we are creating kind of infrastructure, can be used by autonomy. So depends on how this will be implemented in field. Either this is a connection between the power unit and the implement, or wireless communication of machines in the field. But when we start to interconnect cloud systems, immediately AgIN is part of it. And we have already several meetings together where we think about common use cases and immediately also about common data models that can be used while inventing the wheel twice.
I think Alberto did this question because 2 days ago we were talking about one use case where we were seeing how many interfaces do we see into the autonomous system. So as I said before, we were seeing an interface between traction unit and implement, between the system, so traction unit, implement, and the cloud. But the next question was, do we see also interfaces cloud to cloud? So for example, 2 different tools, pet planning tool, talking cloud side with a mission planning tool. And then will be a discussion we're gonna have. But yes, so I agree with Slavi, so no doubt. And we were knowing the answer.
Thank you, thanks.
Okay, it looks it's going to be very complex, but AEF is here to simplify the things a little bit for everybody. At least that's what we try to do every day. I'd like to close this event, and I thank you for being here. Andrew Oliver, chairman of the AEF, is shown on the picture as well, but he had to go back to his Switzerland, right? Swiss, at the end of this morning. I have an information about the following event, which was supposed to take place at 4 o'clock, and talking about the new legislative framework of the European Commission, Artificial Intelligence Act, we told about that this morning, but also Cyber Resilience Act, Data Act, and a lot more. But unfortunately, Ivo Oostens, technical director of SEMA, the European Association, got sick. He was here this morning, but he felt not well and had to cancel, unfortunately, his speech. So I hope he will recover well, and we're not gonna having the next hour of events, but at 5 o'clock there's the press conference of Metos company. So if you'd like to hear about that, come here at 5, and maybe I can just recall a little bit the program about tomorrow, if I can visualize it on my phone, because I'm starting to feel a little tired and I can't recall it in my mind. We have two main events organized by FederUnacoma. The first one is at 10 o'clock. We're talking about, in collaboration with the University of Bologna, we're talking about careers in the new agricultural machinery sectors dealing with the new technologies. And in the afternoon, we're still talking about robotics, perceptions, and AI with several universities across Italy. So it looks like autonomy and data sharing is the most important topic for everybody. Thank you again for being here, and hope you will be back here tomorrow.